Hello, everyone. In this video, we will introduce breadth first search. The breadth first search of a graph is like a breadth first traversal of a tree. With breadth first traversal of a tree, the nodes are visited level by level. First, the root is visited, then all the children of the root, then the grandchildren of the root from left to right, and so on. So let's look at this example now. For the graph, we're going to start from 0. So 0 is visited, then all the neighbors of 0 are visited if they have not been visited. So we're going to visit this 1, 2, 3. This can be in any order. And after this, so we're going to visit the neighbors of this neighbors 1, 2, 3 if they are not visited. So you're going to visit this is going to be the next one is 4. So this is level by level. We're going to implement it using a queue. So this is the algorithm here. Input is the graph consisting of vertices and edges with a starting vertex V. The output is a breadth first search tree rooted at vertex V. This is the method. It returns the search tree. We can create an empty queue for storing vertices to be visited. Add V now into the queue. Mark V visited. While the queue is not empty, dequeue a vertex, say U from the queue. Process U for each neighbor W of U. So this is for each neighbor W of U. If W has not been visited, we're going to add W into the queue. Set U as the parent for W, mark W visited. So this is for each neighbor W of U. So look at this, I have the queue. So first we put 0 into the queue. And now we visit and dequeue 0. So it's visited. And now we put 1, 2, 3, all the neighbors into the queue. All right, so now visit 1 and now put the neighbors of 1, 4 into the queue. So this neighbors, this is 0, 2 already visited, so they're not there. So this is how you maintain the order, the breadth first search order. So this is the algorithm. Let's look at this example here. We're going to start the breadth first search from Chicago. And first visit Chicago, then all the neighbors of Chicago. Seattle, Denver, Kansas City, New York, Boston. And after that, all the neighbors of neighbors. San Francisco, Los Angeles, Dallas, Atlanta, then all the neighbors of this level is Houston, Miami. Here's the test program. This is the vertices and this is the edges. We create a graph using this vertices and edges. Invoke the breadth first search starting from Chicago. And now we're going to display all the results. See the search order and the breadth first search tree. And we're going to display this is see who is my parent. All this information is displayed. Now let's look at the implementation of the breadth first search in the unweighted graph.java. In this class, we implement the breadth first search. It's right here. breadth first search, starting from this vertex, it returns the search tree. We're going to have the search order. It's a list, and the parent initially -1 for each element of this parent is -1. And this is the queue using the linked list. It's now empty queue. So is visited is all now false. We're going to put this queue, this element into the queue. So let's look at the algorithm here. So here is the algorithm. So this is the algorithm. This is the algorithm now. And this is creating an empty queue at V into the queue. And now we're going to have this is visited, V is true. So mark V visited. Why the queue is not empty? So why the queue is not empty? DQ vertex, say U. Process U. So we're going to add this U to the search order. For every edge from the neighbor, this list of U. And we get the adjacent vertex is W. If W has not been visited, we're going to add this W to the queue and set the parent of W to U. Is visited of W is now true. So this is the for loop is repeated for every neighbor of U. Finally, we have this search order, we have the parent, and we have this starting from this V. So this is the root and creating this search tree object. That's all for this video. See you on the next video.